She's ready for soccer day one.
A particle is moving along the x-axis. Its position is given by the following function. Find its velocity and acceleration, and then we want to describe its motion.
You hit the input button on the grade, and it just tells you this grade is rounded. That's all it tells you. Thanks, man. Didn't know that.
So, velocity. Was our notes from the other day?
We got to the T's of velocity and then a line.
Because this is where I showed you how to factor by using reverse FOIL.
Yeah.
And then I drew a line.
Oh, I was reading the whole objective TFWBAT thing and being like,
that. Today's students will be
Could you show us that? Not like take a lot of time on it, but can you just draw that X real quick and show me what the number should get?
Yeah.
Because I don't remember, but I need it.
I'll show you. I think we're going to do another quick job. Yeah, I'll show you an example too. Alright, so velocity, we get t equals 1 and t equals 11/3. So those 2 points are points we need to consider. They are considered critical points. A critical point is potentially an extrema. So it does not have to be an extrema. A critical point does not have to be, but could be. So typically critical points will be change in direction. So what we want to do is compare the velocity on a number line. What do we know about time in terms of velocity at position? It is always positive or non-negative. So we know we're not looking less than 0. We have 1 and we have 11/3. It's sometimes helpful to know what is 11/3 approximately. It doesn't have to be exact. Yeah, like we know it's what, less than 4?
Wait. 3?
And bigger than 3. So that just helps you know what numbers you can plug in. We know we can safely plug in the number 2, and we could safely plug in the number 4, and we can safely plug in the number 1/2. Remember, we don't care what those numbers are. We only care if they are positive or negative. So plugging in a 1/2, it's always easiest to plug into the factored form. So we know the 2 is always positive. If you plug a 1/2 in, 1/2 of 3 is 1.5. That's going to be a negative, right? This is also 1/2 minus 1. So that's smaller than 1. So that's negative, 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 positive. Gives you a negative. Plugging in 2. 3 times 2 is 6. 6 minus 11 will be negative. 2 minus 1 will be positive. Positive, negative, positive. Plugging in 4. 3 times 4 is 12. 12 minus 1. Positive, 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 positive. So that tells you that the motion or movement of our graph, yes.
Do you think it would make sense to write like a range for each of the individual ones? So like, well, we know that 11, since we found those are 0, we know when each of them is negative and positive. So if it's like, you can write like x is less than 11/3, then you know it's negative. And then for the other one, if x is less than 1, you know it's negative.
Oh, I know what you're saying.
This is when you know exactly when this is negative, and you know exactly when this is negative. So then below 11/3, or below 1, then it's negative, negative, positive.
If you like to think like that, I feel like I would make some sort of mathematical error if I did that, but I know what you're saying. Okay, so if it is positive, now we're talking about a particle moving along the x-axis. So now we're talking right versus left, not increase, decrease. So if it is positive, we are moving. Yep. If it's negative, we are moving. And if it's positive, you are moving. That means at 11/3 and 1, the particle is what? Yeah.
Oh.
let's look at acceleration. So a derivative of 6t squared is 12t. Derivative of 28t is negative 28. So you have 12t minus 28. You want to know the zeros of this. If it helps you, you could factor out a 4. Okay, so 7/3, we know we can safely plug in 1. So 3 times 1 is 3. 3 minus 7 is negative. Negative times positive, say negative. Okay, so 7/3, we know we could safely plug in what number above that? 4. 4 times 3 is 12. 12 minus 7 is 5. That's positive, positive, positive. That means, again, we are talking about a particle in motion now. So we're not caring about the concave up or the concave down. We're caring about direction and motion. So if it is negative, it is decelerating. If it's positive, it's accelerating. And we're going to go back and talk about speeding up. Or slowing down. So this is like 2 1/3. And again, 11/3. So that means this value is going to be in the middle here. So we are positive and negative from 0 to 1. So if the signs are opposite, is it speeding up or slowing down? So that means from 0 to 1, this object is slowing down. What about from 1 to 2 1/3? Negative, negative, good. Okay, so from 7/3 to 11/3, this is positive, that is negative, therefore we are 11/3 and on it's positive, 7/3 and on it's positive. So if both are positive, speeding up.
I'm sorry, why is it speeding up at 1 to 7/3?
So at 1, it's negative. At 4 7/3, it's negative. So if these are both negative, it is speeding up. If they're both positive, it's speeding up. Because they're like opposing signs. So negative times a negative actually creates the positive. If the question asks you when is this position function most left? When is the particle the farthest to the left? Farthest to the left? Do we know where the particle started?
0.
-5. So don't forget to check your endpoint if it asks you furthest to the left. So this particle started 5 units to the left. went to the right, and then went back to the left. So we don't know necessarily if at 11/3 it's the furthest to the left, because we don't know the position of the particle at 11/3.
So you just plug in.
You would have to plug 11/3 in to the original. You can use your calculator. I don't think they want to make you plug in that type of fraction in cubic. I'm not.
Is that 2t cubed?
Yes. Hmm? Unofficially?
What?
It's like unofficially.
Yeah.
Did you mess up? Laughing at Josh.
No.
I asked if he plugged in wrong.
No, I just.
Casey is like.
What's the value of 11/3?
13.13.
Negative 13. Okay.
I just had to.
I'll do it.
No, we wanted to know.
Are
You
you
were the
making me all
only
time?
one with the calculator.
I thought
Yes.
everyone was doing it.
Everyone else has it.
Yeah, nobody wanted to
I
get it
am
out.
diligent. in my
That's all we
work.
done.
Mine's
Speaking of that,
back
mine's
there
about to
charging.
die. Yeah, mine needs
Yeah, I was
to
gonna say mine's just charging.
Mine
All right.
hasn't needed
Oh my
battery
God.
changes since I bought it.
Same.
So that's kind of
That
concerning.
could
Like I get anxiety though when it
And then they give me a charger.
I swear about it.
Battery.
You die.
All right. So again, we know that if the derivative is equal to 0, then we need to check and see if it's opposite signs. Now, your textbook puts in there that you can use the second derivative test to check for extremas, but I feel like this sometimes can be more confusing. It's on your papers. You can read it. You can apply it at will. I personally, we're going to do one example like it. I think it's more confusing. So it says use the second derivative test to find the extrema of the first derivative.
Yesterday in our homework it said the concavity test.
That's the second derivative test.
Okay.
So do we take that the original function?
Yep, so there's the original. Find its derivative.
Hanging in, buddy.
Find the second derivative. Yep. Find the zeros of the first and it says using the second derivative. So if it says using the second derivative, you can't use the first.
Yeah.
Okay. We said, do we need that?
No, that's pretty neat.
Okay, so find the zeros of both. So you asked about like doing the magic X with this. You can still do it. Even though this one's not terrible. It would be, if you factored out your 3, you'd be left with x squared minus 4. So the magic X is the first times the last, so 1 times negative 4, which is negative 4. The bottom is the middle number, so that's like what's on the X term, so 0. So you need 2 numbers that multiply to negative 4 and add to 0.
Two.
I would put
Well,
So then if you did this using long FOIL, like it would still work because it'd be x squared minus 2x plus 2x minus 4. And then you'd factor out your GCF of the first 2. I know, but it, like just to reiterate how to do it.
Yeah.
So you'd have x minus 2 plus 2, x minus 2. So then you see your 3x minus 2, 3x plus 2.
I
So it
that
still
is
works.
so cool. That
It's
is so cool.
yeah.
I just
like it still works if you forgot difference of squares.
No, I'm genuinely that's.
So I felt like that wall.
Listen, oh, yeah,
I know, I just, it blows my mind.
Okay?
Big chunk.
Your zeros are 2 and negative 2. And then these are your critical points. So those are your possible extrema. So the way the new thing reads is if f prime of c equals 0, so it does, our c values are 2 and negative 2, then the second derivative sign tells us if they're an extrema or not. So what we want to know is, okay, what is the sign of the second derivative at 2, and what is the sign of the second derivative at negative 2?
C.
So the second derivative at negative 2 will be negative 12, therefore less than 0. The sign of the second derivative at positive 2 will be 12, so greater than 0. So that means since negative 2 is negative on the second derivative, negative 2 is negative on the second derivative, then we have a max on the original. Right? See, I think that's confusing.
I like the
You
other
just say.
Like concave down would be. See, I got the ball.
So the second derivative test for extrema says if the first derivative is equal to 0 and the second derivative is negative, then you have a max on the original. So your critical points, this is negative, then it is a max. This is positive, and this is a min.
I mean, like, I get it, but I like the. Is this like the same?
It's the
thing
number
as
line
reverse?
without doing the number line.
Okay.
So, like, you could do, whoops, it would be red. You would say, oh, here's my negative 2, here's my 2, and then you check your signs.
That's much more better.
I think so too. But,
Yes, sir.
so if you plugged in like 0, then we get a negative. If you plug in something positive like 4 or 3, 3 minus 2 is positive, positive, positive. Negative here, so negative 4, that makes that a negative, that makes that a negative, which makes this a positive. So increase, I'll do it. Increase, decrease, increase, max, min. Max is what we said. There you go.
Do we have to use this?
No.
Okay.
Negative, negative, that means this is concave down. Positive, positive, concave up. It doesn't ask you for it, but what does that make? 0?
If you
If I ask you to, could you sketch the original graph knowing all of this information?
No chance.
Nope.
yeah, just
Yeah.
like
We really need to know.
I mean, roughly.
it'd
Very
be like
roughly. Look like that.
Know where the main points are, then you know it's kind of sweet. This is
Yeah.
real life.
exactly.
It's not specific location.
You right here.
All I have to do is.
You solve for 0.
Eugene
Wait.
Bird.
So 3,
You just solve for each of the points you have, then choose between.
You got, all you have to do is plug in the local maximum.
Harden. Yeah, it's
And
not-
it'll just kind of swoosh it around.
Good. Because guess what we're going to do?
I did not want to do that. That's not what I intended.
Do you think he's looking in the newspaper to see our names? Coach
Okay, find your, oops, just
Harden.
kidding.
Briggs. Coach Briggs.
So, Here's the thing, this does not give you the original function. We do not know the original function. What do we know about the original function? It is what type of function?
I would put up forward a quad.
Quad 4, you get me?
Quad.
A quad 4 has a name. Anybody know it?
You're
Quartic.
kidding me.
There you go. Quartic.
Is that 5?
That's Quintic.
Quartic is 5.
Quintic.
Quad 4.
What's 6? That's 20.
6th degree.
Picnic on it.
Okay? So this represents the derivative. So find your zeros of the derivative. Always factor out your DCF. What does it mean when you can factor out an x squared twice? So what does that mean when we can factor out an x squared and it's out in front? X equals 0 is a...
Asymptote.
It would be, it's 2 words. They're alliterate, meaning that both words start with the same letter.
I'm illiterate.
Yeah, I'm illiterate.
Yeah.
2 words. First letters. Give us the first letters.
Solve the equation.
Reverse reciprocal.
Wait, are the R's the first letters?
Hmm.
Bracket right off.
That starts with a W.
Yeah.
He said it. No, I said it. I thought it was funny.
Real rational? Rational real.
Real rude.
It's spelled like the REK.
What kind of races?
You're not gonna tell us.
Ronnie
We're
Ruba.
not gonna
Russian
guess it.
Roomba.
That's right.
Russian Roulette.
Repeated root. See, I wouldn't know.
I was definitely gonna guess steel ladders.
What does, if it's a repeated root, what it means is that you have the same root value twice. That's gonna play a role in a minute.
Line. I can draw a line.
Okay. We need to know what's happening on the derivative around those critical points. Remember, critical points are possible extrema. Possible. So, what's happening at -1?
Is that F prime?
It's -1. Negative.
At +1?
Negative.
At 4?
Is it like even out?
So 0 isn't like
delay.
So 0 is not, exactly, 0 is not an extrema. 0 is not an extrema. It means the graph is decreasing and continues to decrease until 3, and then at 3, it goes to increase. Yes, Josh.
So we just pick a point on the other side of the road.
Yeah.
And we can assume that range is entirely negative. Or whatever sign it is.
Yes.
Because.
Yes.
Okay.
I just don't want you to say anything and confuse anybody else. And I knew you were thinking right, so I was like, yes. Okay, F double prime. Derivative of 4x cubed.
Prime is there.
Wait, what? 12x squared minus 24x. That's 24.
The 2. Okay, factor out your 12x. Be friends.
Straight.
Okay, what are your zeros?
0 and 2.
Those he said over.
Put them on your number line. What's happening left of 0?
Not positive.
Yep, because that would be a negative, negative. Plugging in 1
Negative.
and 3. So we have concave up, concave down, concave up. That means that 0 and 2
That's a good show.
What is x equals 3?
It could be. No, it's top 10 anyway.
Okay, let's graph this using what we know.
Oh, wait.
What?
there was a-
Did you write it in the wrong spot?
Yeah.
Just box it and draw an arrow.
Oh, I'm so upset.
But
All right. What the heck?
in all fairness, so did I, because I didn't change to slide B.
This,
Right.
okay. Oh, man. Everyone's so neat, too.
Where are you going to do this? It's on the next slide.
I did how?
We can do that.
Because I did it last year.
Let's do your pen use.
Oh, let me show you. You're now
Okay.
raising
Oh, no kidding.
Hey, I saw the answer.
Whoa.
Here's the thing. You don't know your original function. So you have no way of knowing the actual coordinates. So what I'm going to do, no, I'm going to tell you 2 coordinates.
Okay.
And then you have to use those to graph the rest of it. So, f of 0, we will say, is 0. And f of 3, we'll call negative 3. Sketch yourself out the remaining.
Well, I have 2 points.
Just draw a line between.
I would like to see concavities. I'd like to see POIs marked. So we know you have POIs at 0 and 2. So you want to make sure you change your concavity at 0 and at 2.
I already know the joke. Scared.
I winged it.
I think we're wrong. Yeah, I don't know.
Shut up.
Okay?
Oh,
You're-
wait.
Go ahead, what?
They forgot about the 0.
I was right.
Your graph should look approximately like that. You should have it concave up, concave down, a 2, concave up, and remain concave up.
I would never.
In a perfect world.
It doesn't go exactly through the point.
May we have a formula?
I'm going to do one last example, and then you get your break and homework.
This guy gotta go to
Do you really?
Well, I can like.
The running.
No, I said example
Yeah,
4. I didn't say it's going to only be 4 minutes.
Yeah, some talk.
Well, he said deceiving.
Gross.
that word is like.
Okay.
Versus thing.
There is usually a question like this on the AP test. The difference is, and we're going to do it because we want to practice our math, they will give you F, F prime, and F double prime to start. And then ask you questions about it.
Oh, you just want to make us do that.
I don't have to find
I
it.
do want to make you do Hody High minus Hody Ho because I want you to practice.
I don't need more time.
What I would do before I start this problem is determine what is my domain.
All rules except that, yeah.
Good. Can I ask you for the intercepts after that?
Yeah.
Okay. What's an easy thing to find are always our intercepts. So that's when x equals 0 and y equals 0. So when x equals 0, what is y? Okay, so my x and y intercepts in this case are the you forgot how to find them. To find your x-intercepts, you set y equal to 0. Y-intercepts, you set x equal to 0.
So 0, 0 is
Yes.
0, 0 looks like an owl.
Yes.
It does.
Okay?
Google.
Is this function even, odd, or neither?
Good question.
So, to figure that out, remember you plug in f of negative x. If you get the original, it is,
Even.
if you get the opposite of the original, it is,
Oh,
if
okay.
you get anything else, then it is,
Can you say that again?
I got all three right.
Can you say all three of them over again?
yes. When you plug in negative x, if you get the original, it is even. When you plug in negative x, if you get the opposite of the original, meaning I have like a negative hanging out here,
Uh-huh.
it's odd.
Okay.
Anything else is neither.
No, you can't.
All right.
So a negative squared is,
Positive.
Wait a minute.
Yep. So I can't bring out a negative and have anything with the original. Because even if I brought this negative out and brought it up front, then this would be minus 8. So that's not the original. Therefore, this is if it's not even or odd, the reason you check for it is it tells you about symmetry. So if it's like even, then we know you can cut it down the y-axis, fold it on top, and we're good. If it's odd, it's cut, fold, fold. So really we don't have any help with that. How about vertical asymptotes? So to find a vertical asymptote, you set the denominator equal to 0, solving for your x. So again, what that tells you is on your graph, at x equals negative 8, we have vertical asymptote. So right now, I would just throw in a dashed line on my graph at negative 8.
You're not going to see dashes.
Okay?
I'm doing a little horizontal line.
I'm doing big dashes.
All right.
Big chunk of
Do we have a horizontal asymptote?
Is it at 0? No.
So there's not-
So is it 1?
No.
The numerator is bigger than the denominator. Wait, no, it's at.
The numerator is bigger than the denominator, then it is a,
Oh. Then 1 is at 0?
if the denominator is bigger than the numerator by 1.
Oh yeah, that actually makes a lot of sense.
Wait, what? Repeat that.
Also,
Okay.
If the numerator is bigger than the denominator, just like that. If the denominator is bigger than the numerator, it's 0. And it's equal to that.
Does she not?
2 cents.
Okay. So we have a horizontal asymptote that is a slant.
Do you
To find a slant asymptote, you have to do long division.
You go for it.
That's not that fast.
But you have to multiply x by to get x squared. So you get x times x, which is x squared, x times 8. And you subtract them, so you get 0. But you have to multiply x by to get negative 8x. This is your equation of the slant. You don't have to find a remainder. That is the equation of a line. Slope, y-intercept. So, like, none of the rest of it matters. Does that make sense? You're not trying to actually solve long division. You just want the equation of the slant. The remainder isn't going to affect the slant. Party. A party of who high. Mine is how do you? I'll never have
No,
hope.
thanks.
I like my vote.
Find your derivative. Maybe if I teach you, I should have.
Oh,
She's doing this year.
No.
We knew it when we were you. I just never thought about that. I love frozen ho-hos.
Every time you say
Are they
this, just
crunchy?
put one out of class.
What?
Really
Brutal
crunchy.
fight for that thing.
No.
I just don't like
I just
cold
really
chocolate.
It's more like a pie. Did you do your hoodie on ice cream?
Yes, I did.
Okay. Did Destin? Did you simplify? Combine like terms?
In my defense, I think I had a drink that was frozen last night.
How is it defending what?
Exactly.
We're talking about, at least we're somewhat on top.
Josh, did you find a common? Did you simplify your numerator?
What?
Did you
What?
simplify your numerator?
Yes.
What did you get?
Is it from the what?
X.
C did not.
Times X plus 16.
What?
I got that too.
Be high.
Did you factor out your x?
Yeah.
Yes.
Yeah. Why not? Might as well.
That's
am
the
I right?
question. Today's a Monday.
I just didn't have fun time watching this video.
I should never go.
Okay. When is the derivative going to equal 0?
When x is 0.
And?
Negative 8.
No.
Why?
That's when it does not exist.
You do.
Negative
Yeah,
16.
it is.
Negative 16.
What? I thought.
Go ahead, Casey.
Yeah, that's fine.
You gotta set the numerator equal to 0, right?
I thought when it said
You have to divide
denominator
it
equals
like
0 too.
That's when it does not exist.
Yeah, I thought we used those too.
Yes, but I only asked for 0. Like, I didn't say you're wrong. I said that's when it does not exist.
Oh.
Like, do you see what I'm saying?
Yeah.
Like, this is the DNE.
Oh.
This is the zeros.
Okay. Okay.
So they're all critical points. They're just two different types
Okay.
of critical points.
I'm a
Why
rhino.
why are we talking about
I don't know why they're talking about anything. I'm ignoring.
All I heard was
Love doesn't just spell.
Okay? Find out what's happening around your critical points.
Well, it doesn't exist today.
So what I did is draw in my vertical asymptote, if I haven't already put it on the graph. Because what's that going to tell you about plugging in numbers to the left and to the right of it? Something else. Something like that. there's vertical asymptotes, then your graph has to be going to an infinity. So if it is negative to the left, now again, we're talking about the derivative, so it doesn't tell you what infinity it's going to. The negative tells you it is decreasing or increasing if it's positive. So it doesn't tell you what infinity it's going to. Yes?
So since, okay, so I figured it out. So since between 16 and 8, they both negative. That's negative, and then after that's negative, is it a removable discontinuity? Because how would an asymptote be both negative if one is always, like, you know what I'm getting at?
No.
Alright, so okay.
Okay.
Like,
But that's not what this is going to look like necessarily, because
so what would
when
it
you
look
drew
like?
that,
It's
that's
like that.
decreasing,
If
that's
that's
increasing.
And it's either
But if
negative,
these are both decreasing,
so what would it look
then they have to both be, so this one, that's decreasing,
like? And how it's
that's decreasing.
oh, that's what it is. Okay.
So that's why I tell you go up,
Enlighten.
down, down,
Alright.
up. We start this one up here again because of the asymptote. If there was no asymptote and it went minus minus, you'd keep your negatives going this way. Find your second derivative.
I'm out of room.
Yeah, please tell me that's that.
I believe so.
That says we're
Second
at
derivative.
point of inflection.
I like AP better. They gave us the first and second derivatives.
Cody.
Oh, there's an explicit on both sides.
Oh, good. The insights in class.
No, right here.
I ran out of room on this one, going sideways.
That's why I was like walking back and looking at my work again, going, okay. Oh. 3 high minus 5. 3 ho.
Well,
Is it the x plus 8 to the 23rd?
Oh, why?
What's x plus 8 to the 23rd?
No, it's
alpha
she
too.
crossed off two.
Oh, I used to do.
Sorry.
Well, I saw the L. I just didn't realize it.
just to the third.
Yeah, because if you square would be the fourth.
Mm-hmm.
And then you're able to cancel.
Yeah, because there's one in each of them.
Cancel off that one.
Please don't distribute all of those. So you factor theta,
Oh, I distributed.
I distributed.
I know, I'm just lazy. What's 8 times 16?
Okay, I got 146, but I don't know if that's right. 136. I'll take your report.
Definitely not right.
No, wait.
It can't be, because 8 times 6 is 42, and 80, so it'd be 130. I mean, 122.
Wait, it's the good shoes, but
Do you have 122?
Wait, it's 128.
It is 1.
Oh, it's 8 times.
8 times 6 is 48.
8 times
80.
16.
Oh, it's 48. Yeah, you said 42.
Oh, I said
48.
it was 56.
Holy.
8 times 6
That is
48.
That's 128.
128.
Just back to that too.
Could have. Yeah.
That made it a lot easier.
Get a little bit hungry. There's nothing really good right now.
So your squareds cancel. Your 32x's cancel. So you're left with.
Wait, what?
What
Can-
is it?
32
128.
So, does this graph have any POIs? No. Because can 128 ever equal 0? If the denominator equals 0, it is going to be an asymptote because of the repeated explicate.
Oh, that's just a mistake.
Cool.
So no POI.
No.
Is this graph concave up or concave down? Now, here's the problem. You have to know if it's concave up or concave down around -8. Because of the DNE, this is still going to potentially be a sign change. So if you plug in 0, because we like 0 and 0 is easy, 0 plus 8 is 8, 8 cubed is positive, positive, positive. You plug in something bigger than -8, let's say -10. -10 plus 8 is -2. A negative cubed is, therefore this is,
I mean, that makes sense. 'Cause it goes like that.
exactly.
You like this dog now? No.
Okay, let's sketch this.
Oh, yeah, but it's not-
Your graph is a little goofy because it doesn't go to the -16. I know you drew in your asymptotes. Some of you did it in pen. You could actually make -4, -8, make -8, 16 in pen. I mean, just you could ignore your dashed line.
No, I didn't.
Yeah, you could just. I'm graphing with my hand on the back.
That's gross.
Why? It's a sketch, not a perfection.
Yeah, it's a lot.
That's a girl.
Oh,
It's actually not that bad. It's a lot better than
that's
the
so
other
real.
Go for it, Lynn.
Oh,
It's actually not that bad.
All right. So we know that our graph has a point where. What's one point we already discovered?
Wait.
No, that is like 0, 0.
The one
Thank
point that
you.
doesn't exist.
0, 0. We know that the graph does not exist at -8. It is a vertical asymptote. What other asymptote do I know?
The slant asymptote.
Yeah, that goes through -8. My paper fell. Hence why I put -8, -16, and +8, because those are kind of like points on my line. Because it slips 1 over 1. Okay? So just again, going through all the things we know. We did A, we did B, we talked about D, we talked about E now. -16 is a max. So what could you do to find out where that max is? You could plug it in. So, but that's going to be a very, very kind of gross number with the -16 squared. So 16 squared is, anybody know?
Yeah, sure.
256. So 256 divided by -8.
You're looking at
32.
33.
32.
32.
32.
Yeah, that's pretty close.
Okay? So that tells you negative 16's at negative 32.
That's
That means we gotta draw it farther.
Wait.
Yeah.
Yeet.
I'm just
Skelter,
I'm just
skelter.
writing it down.
Wait, it passes through that.
After the vertical. No, this asymptote, it's going to be below it. But yes, it can pass through a slant asymptote.
I don't think what is there. What? Oh wait, no. So there's just no existing point on the asymptote.
Correct.
So it's like a hole in the graph.
Oh, wait.
I think, well, that's hard.
It's like a hole in the graph as it's
Trying
trying
to
to
make change for a living.
So you're going to make change for a
There's
living.
not people who can't do that.
I'm gonna say a little
Mr. Manning
something.
had a whole rant about that.
Yeah.
Wait, what?
Making change, people who can't make change.
It's not like lazy people.
Okay. To the left, or that's what's happening to the left, way down here. To the right, this is decreasing, increasing. Your min is at 0, 0. And you talk about concavity. It is always
Oh, well,
How do we know how super
okay. This one's way down here. It's going to follow that asymptote and come back over here and follow. Whoops.
Not a good day to miss.
Follow this asymptote. So it's like way down there, but do you see kind of how like it's going to follow the slant? So it doesn't necessarily go through the slant. I don't know where you're seeing that. Because this is going to be following the slant here. And that's going to follow it down there.
Is that slant?
again, I can't visualize graphs.
Okay.
Like,
Wait, what graph
Visualize.
is this? Is that like the original function or is that a derivative?
I'm taking shots in the dark from that one.
What's a slant?
The slant is an asymptote of the original.
The graph
How's
is
that-
not to
Is
scale.
that like found?
Not at all.
That was when we did
Oh, well,
this.
what are you gonna do?
Like X, Y, Z?
No, I think it was Oh, you.
Because I used to
Oh,
like
you
see
got
graphs
weight?
on the right like that, and I don't know what the beginning was.
Wow. Whoa.